We've already covered how to symbolize sentences into sentential logic, and now we're going to get started into how we can actually use and assess them. As I mentioned when I first introduced the truth functional connectives, they're called truth functional because we have what are called characteristic truth tables that assign truth values to compound sentences based on the truth values of their component parts. In this video, I'm going to teach you why we use truth tables, how to construct them, and then I'm going to show you the characteristic truth tables for each connective. So since we're in a formal system now, we're not concerned with the actual truth values of particular sentences at all. So what we're going to look at from here is the possible truth values of sentences and arguments. That's what truth tables are for. It's structured in a way to organize all of the possible truth values of the atomic sentences involved, and from there we can assess the truth values of compound sentences using the characteristic truth tables of the connectives. Learning the basic characteristic truth tables is crucial for being able to assess more complex sentences and arguments later on. So with truth functional sentences, each one has two possible truth values. It is either true or false. So a truth table with only one atomic sentence has only two rows, one in which the sentence is true and one in which the sentence is false. And then it gets more complicated from there. When we're looking at a sentence or arguments involving two atomic sentences, we need to capture all the possible combinations of the sentence's truth values. So we need 4 rows. Filling out a truth table is formulaic. In the first column, you do half true and half false, like this. In the second column, we alternate the truth and false values for that second atomic sentence. In this case, we're using Q. This method allows us to capture all of the possible combinations of the truth values of P and Q. So when P is true and Q is true, all the way down to when they're both false and both of the alternations in between. Most characteristic truth tables will include 2 atomic sentences because we mostly deal with binary connectives. So the first 2 columns will always look exactly like this. When we start assessing complex sentences, we'll often have 3 atomic sentences. Every time we add another atomic sentence, we double the length of the truth table. So here, with 3 atomic sentences, we need 8 rows. In a later video, I'm going to teach you a shortcut method to avoid lengthy truth tables, but you should be comfortable creating and working with 8-row truth tables. So here's the methodology for filling out the possibilities. In the first column, you're going to do half true and half false. So 4 rows of T and 4 rows of F. In the second column, you're going to split that number in half again. You're going to fill in 2 rows of T, then 2 rows of F, then two rows of T again, and 2 rows of F again. In the third row, you divide the number of T, you divide the number in half again, right? Before we were doing 2. So now we're just going to alternate directly. So you're alternating T's and F's all the way down. In each of these columns, we have 4 trues and 4 falses, just alternating differently. And this methodology ensures that we capture all of the possible combinations. Now, I don't think we're ever going to ask you to do a truth table with 4 atomic sentences for homeworks or for tests. We're going to give you a shortcut method to get away from having to do this, but the process would be the same. You'd have 16 rows, and in the first column, you'd divide the number of rows in half and do 8 true and then 8 false. For the second row, you'd divide that number in half again, and starting with 4 true and then 4 false, and then you'd repeat that. For the third row, you'd divide that in half again, right? You'd alternate 2 true, then 2 false until you reach the bottom. And then in the last row, for the 4th atomic sentence, you'd alternate true and false one at a time. I know this is tedious, but I hate to see students get a problem wrong because of not formatting the possible truth values in their tables correctly. This is also why I strongly recommend students use graph paper. We can deal with truth tables 4, 8, or sometimes even 16 rows long. And I've seen students lose points because they didn't keep their rows straight or their columns straight when doing assessments and getting confused. Fortunately for all of us, we only have unary and binary connectives. So the longest characteristic truth table that you have to memorize are only 4 rows. So let's get into those truth tables now. Negation has the simplest characteristic truth table by far. It's a unary connective, so we only have 2 rows, and the negation just flips the truth value of the sentence. It modifies a T into an F and vice versa. Conjunction and all of the other binary connectives have 4-row truth tables. Conjunction is a fairly easy one to remember. It is only true when both conjuncts are true, as you can see on row 1 of the table, and it's false otherwise. So if one or both of the conjuncts are false, then the conjunction itself is false. Disjunction is also a fairly intuitive truth table. It's only false when both disjuncts are false, and it's true otherwise. So row 4, where they're both false, is the only time a disjunction is false. Row 1 shows why disjunction must always be the inclusive sense of or, why we have to do so much more work to capture that exclusive sense. On our truth table for disjunction, the disjunction is true when both disjuncts are true. And we'll look at a truth table for that exclusive or, that complex sentence, in the next video. So here's the truth table for the material conditional. This one usually seems to be the hardest for students to remember. The trick is material conditionals are only false when the antecedent is true and when the consequent is false, as you can see in row 2. The best way I can figure out to explain it is that only the second row of the truth table disproves the conditional claim. Take the example, if it's raining, then the ground is wet. On the first row, it's both true that it's raining and it's true that the ground is wet. This seems to confirm the conditional relationship. On the third row, it's not raining, but the ground is wet anyway. That doesn't seem to show that the conditional, if it's raining, then the ground would be wet, is wrong, right? The ground might be wet because I washed my car. On the fourth row, it's not raining and the ground isn't wet. This doesn't show anything about the truth of the claim that the ground would be wet if it had been raining. Only the second row, on which it is raining but the ground is not wet, invalidates the claim that if it's raining, then the ground will be wet. I'm not sure that type of explanation is actually super helpful to students. Truly, if it's not, you just need to memorize that a material conditional is only false when the antecedent is true and the consequent is false, and that it's true in all other cases. I know it's kind of counterintuitive. It's not as easy as the other characteristic truth tables to remember, but it's one that you just have to commit to memory. Last, we have the truth table for the material biconditional. This one has a fairly easy memory trick. Biconditionals are true when the truth values of its component parts match. That's whether that's both being true, like row 1, or both of them being false, like row 4. Biconditionals are false anytime the truth values of the 2 component parts are mismatched, like row 3 and row 4. To avoid making this video too long, I'm going to end this lesson here. The characteristic truth tables and how they work are also covered on these pages of the logic book and at the very beginning of lesson 3 in the course manual. In the next 2 lessons, we're going to start using truth tables to assess the logical properties of sentences and arguments. Once you get through those, you'll be able to start working on problems.